Okay, we're going to do a couple of examples of using Laplace transforms to solve initial value problems. So our first step is going to be to take the Laplace transform of both sides. So we're going to be using here, you probably want your formula sheet out with you, but the Laplace transform of y prime is going to be s times y minus little y at 0. The Laplace transform of y double prime is s squared capital Y minus s y at 0 minus y prime at 0. Where here we're writing Laplace transform of y just with a capital Y. Okay, so we're going to take the Laplace transform of both sides. On our right hand side we have s squared y minus s times y at 0 minus y prime at 0. Then we want to subtract off the Laplace transform of y prime. We're going to use parentheses, s times a capital Y minus little y at 0. And then we have minus 6 times Laplace transform of little y, which we're writing just as capital Y. On the right-hand side, we have the Laplace transform of 0, which is just equal to 0. And the way that we use these initial conditions, y at 0 is 1, y prime at 0 equals -1. So we're just going to plug them in where we see them in our expression. So this gives us s squared capital Y minus s times 1 minus a -1. So I'm going to write +1 minus s times y minus 1 minus 6 times y equals 0. And now we have an algebra problem to solve. So I'm trying to find y for capital Y. So I'm going to solve for capital Y and then take the inverse Laplace transform of both sides. So in order to do this, I'm going to write the terms that have, we're going to move the terms without y's as a factor to one side, and everything that does have y as a factor we'll keep on the other side, and we're just going to do a little algebra because we see y here and here and here. So let's check this out. We have s squared minus s minus 6 times y on the left side is going to be equal to s minus 1 minus 1 on the right. So the right hand side here we have minus s becomes plus s, plus 1 becomes minus 1, and then negative 1 gives us another plus 1. So all told, this is equal to s minus 2. All right, and so we are now able to solve for y. Solving for y, we have y is going to be equal to s minus 2 divided by s squared minus s minus 6. Okay, so we don't necessarily see this guy on our list. What we're going to try and do is factor our bottom. So the denominator we can factor up as s minus 3 times s plus 2. And so we can find a partial fraction decomposition for this expression. Our terms are going to have just denominators of s minus 3 and s plus 2. So I'm going to use cover up method here to find these values. To find a, we're going to be evaluating s minus 2 over s plus 2 when s equals 3. So we're going to be plugging in, the value 3. And basically, we're just removing that one term and plugging in 3 everywhere else. All right, this gives us 3 minus 2 over 3 plus 2, or 5, 1/5 rather. And for B, okay, same story. We're going to be covering up this s plus 2 term. And so we're evaluating s minus 2 over s minus 3, where s equals -2. So we're going to be plugging in this -2, which makes our denominator of the b term equal to 0. Okay, and plugging this in, we have -4 over -5, or 4/5. Okay. All right, so we are almost done with this. We have that capital Y, this Laplace transform, is equal to 1/5 times 1 over s minus 3 plus 4/5 times 1 over s minus -2. And so we're going to take the inverse Laplace transform of both sides. The inverse Laplace transform of big Y is little y. The constant multiples just come, these scalars multiplying just come along. And we have e to the 3t plus 4/5 e to the -2t. And notice that we get our answer right away. We've included the initial conditions when we're actually solving the problem. And so this is kind of a different style from finding the general solution and then like matching initial conditions. Here, those initial conditions are sort of part of our structure here that help us find those unknowns A and B in our partial fraction decomposition. So we're all done. Okay, let's try another.